They start off nice, and they will get a little bit ugly, but not that much. And then you get to practice. All right, so we've got two numbers that have a sum of 45, and we all know sum is code for adding, that's right. And a difference of, so that's subtract. So do we know what the two numbers are? No, we don't know what the two numbers are. So let's be crazy and call one X and the other one Y. How creative are we? Some of you could have called them A and B, but anyway. So we'll let one number be X and one number be Y. So when we've got two numbers that sum together give me 45, how would I write that? X plus Y equals 45. And they have a difference of 13. So X take Y equals 13. I would argue here that it's not even worth turning on your calculator for this. No way, Jose, because it's set up so beautifully to do elimination. Would you agree? And remember, what had to happen for us to use elimination? Got to tell Slavi. What had to happen? Tell him. Wait. Are you listening, Slavs? Yep.
Has to have the same
What has to be the same?
two numbers, like Y and Y or X and X.
Right, so the coefficient, remember the number in front of the variable, right? The coefficient has to be the same. And you can see here that, yes, there's technically just a 1 and a 1 in front of the X. Excellent, Ella. And even the Y. 1 minus 1, we don't care if it's positive or negative, as long as it's the same, like, number, yeah? So, what would you like to do here? What would you like? Would you like to add them or subtract them? Ooh, so if we're subtracting, that means we're getting rid of the X's, agreed? So we subtract, and they were allowed to do this, Slavs. X, take X, no X, they've been eliminated. What's 1Y, take 2Y? Ooh, I said 2Y. Take Y becomes 2Y, my mind jumps. And what's 45, take 13? 32, therefore Y has to be 16. Now, how do we get our X value? Sub. Which one would you sub into? And so a lot of you, yep, you could go top, you could go bottom. I'd actually go bottom because the numbers are smaller. And it's Friday for me. And I'm done. Anyway, so it's X take 16 equals 13. How do I get rid of the take? Add. Huzzah? Right? You could have, depending on, don't write this bit down, and you really didn't need to do the other if you didn't want to, but we've got this one. If instead of taking the equations, what if I added? Are you too cold back there? I can turn it off. You all right? Right? X plus X, I get 2X. What's Y plus minus Y? No Y. They've disappeared. 40, 58. And what's half of 58? Oh my God, 29. So it doesn't really matter which way you do it because they both have the same numbers there, right? Options. So they're going to start off nice and simple like that, and then you're going to get to crazy ones. Well, not even crazy, a little bit annoying ones. You know, I bought so many pens and so many pencils and it cost me $14. Then I bought a different number of pens and a different number of pencils and it cost me $20. What's the cost of each pen and pencil? It's like, geez, mathematicians, give us a break. So, we ready to dive in? We will have a heading, exercise 16D. Today's date is the 4th. We're going to get practice. Probably most of these would be elimination, you'll see. But then we're going to get to the point we're going, you know what, we're a little bit over the algebra. As long as we can get our equations here, can we then solve it using our technology? All right? So that's where we're heading. We all good? Okay. Awesome. So here we go. Would you like to have a go at question 1? All by your lonesome? Sum of two numbers is 72. Do you know what the two numbers are? No, you don't. I mean, you could guess. So we say x plus y is 72. Their difference is 40. X take y equals 40, right? Personally, I would add these together because I can see the y's will cancel out. If you didn't do that, that's okay. We should still end up with the same answer. 112. Is that right? Yep. Yep. And half of 112. And therefore, x plus y equals 72. So y would be 72, take 66, which is 6. Huh? Yeah, who told me that? 56. I was going to say, I didn't think it was. And so we've got 16. All right, even though we don't need to double check, let's grab our calculators. So we're going to grab our calculators. If it's in anything else, right? Yes, we're going to press the on button here. If it's in anything else, right? So I'm in something else. All we have to do, exit and press menu. Right? Exit menu. So, who remembers where we go to solve well done, look at you. Didn't do it before and now into equation. So it's the orange one. We press enter. And even if you haven't done this ever before, have a read. What one do you think we're going to go to? Simultaneous, that's right. And so it says F1. So that's the little buttons underneath. We press F1. Probably don't even need me now, because what are we going to press next? F1 again, because number of unknowns is 2. Our equations are in this form. What was it? 1, 1, 72. So 1, 1, 72. Enter. What's our other equation? 1 minus 1, 40. Now, peeps, even though your calculators are so good, when you go 1, enter, this one here, this is your negative sign, right? Not take 1. Negative 1. Negative 1. The calculators, when they first started, they would be really picky about which one you used, right? Now, they're so good, they sort of go, oh, students just go, whatever. But I still hate it when I see people entering that. But anyway, that's just me. Huzzah! And you can check. Okay? In my day, I would just sub it back into each equation, get the right answer. I know that I'm right. All right? So have a little bit of a discussion amongst your neighbours and let's see if we can get an equation for the next 2 questions. Pardon? Love it. Yep, so we heard x minus y over 2, because that's half their difference, equals 7. You could have written a half x take y equals 7. And yes, JP, what did you say? Just double it. So you could say x take y equals 14. All of those are fantastic. Awesome. Right? And then you could solve. Again, I'd like to think that you could solve. If you went with this one and JP's, you could solve that faster than if you went to your calculator. So you're checking both ways now. In the test, if it doesn't say solve algebraically, feel free to use your calculator. Calculator. So we've got our, sorry, didn't record, but we said let x be the smaller number, so y is 3 times the size of, and the difference between the 2 numbers is 34. I accidentally put a 3 in there. So now I'm just going to sub y equals 3x, so I'm going to sub it in there, 3x take x equals 34, and I think we can solve it from here. And therefore y is going to be 3 times that. Pretty groovy? Yep. Let's hope they sell coconuts and bananas in Jamaica. But yes, you can see if you bought 5 coconuts, 14 bananas, they cost $8.70. So let each coconut cost X cents and each banana cost Y. I tend to, when I have questions like this, I let it be C and B, so I know which one is which. C for coconuts, B for bananas. But if you want to stick with X and Y, go for it. But you can see 5x plus 14y equals 870. Right, all they've done is they've changed it to cents. Personally, I would have kept it as $8, 8.7. I don't mind working with decimals. And you then got 8 coconuts and 9 bananas. Sorry, that makes me chuckle. Right, again, equals 990. I would have put $9.90, so 9.9. Now, what have they done? They've decided to eliminate the x's, so what's the number that 5 and x both go into? 40, and they've done the whole thing, timesing it by, right? You've got your graphic, you've got your scientific calculator, so you don't have to do all of that stuff in your head. You can do it quite easily. So, oh, we got fish and chips. Let's have a look. Feel free to go ahead if you so desire. Because people will go, why has she got that there? So this is now what we had before when we want to solve simultaneously. And I think for the problem solving, this will be the last one we're going to do algebraically, and then I think just hit your calculator. So, big decision. Do you want to get rid of the F, the fish, or do you want to get rid of the chips? Chips. Chips. Right? Why did you choose, I'll come back. Why did you choose chips? Or if we're in New Zealand, chops. I don't know. Oh, just okay. I'm feeling hungry now talking about chips. But anyway, well, you're asking yourself, what's the number that 2 and 3 both go into? 6. Smaller than, what's the number that 15? So, but if some of you out there went, you know what? I'm okay with 15 because it's just getting rid of the number at the front. Do it. You are not wrong. Are you happy to go for the 6? So here we go. I have to times that clearly. If we're getting rid of the C, I have to times that by 3. And we have to times that by 2. So let's go to it. I hope you concur with that. And what are we going to do? Ado up the back. What are we going to do? Add or take? Sorry? If you add, right, 9f plus 10f, 19f. What's 6c plus 6c? Ooh, 12c. What did we want to do? We wanted to eliminate. That's made it worse. So don't add, just go subtract. So you don't have to think, just try one. If it doesn't work, it's a 50-50 shot. Do the other. But basically, same sign, subtract. Different sign, add. So, 9f take 10f minus 1f. They disappear. 24.3 take 26.5 is minus 2. What happens to the negatives? Yep, they just cancel out. And I'll be honest with you, when I see this, I actually go bottom, take top. I don't even have the negatives. Anyway, they've gone. So therefore, our fish is costing us $2.20. If that's whiting, that's a bargain. And how will we find the cost of our chips? You substitute it back in. I will leave that for you to do. But no, someone just frowned at me, so I will do it. So I will sub that back into the first one. So it becomes 3 times the cost of the fish, which is $2.20, plus 2C equals $8.10. And then to get rid of that plus, I'm going to subtract. I'm so lazy, I'm not touching my calculator, even though I guess I could say 6.6, but I'm just showing you, if you get worse numbers, right, you don't have to use your calculator until the very end. You want to try and use your calculator once. Thanks, guys. Hopefully what you have established is we've gone on where people are doing question number 6. We're happy with that. I hope you actually read the example. Then you're doing question number 6. We've got Andre, yes, and I think some of you might get a bit of a... It's just the way your mind works with 8, but we'll go through those very quickly. But hopefully what you have discovered is it's in the last little statement that's going to help you. So how many of each coin type does she have? That's where you say, well, I'm trying to find the number of coins of each one. So X be the number of 50 cents, Y be the number of 10 cents. Yes, my friend. Yes, yes, I'll come and show you. But what does the little dashes mean? So equilateral, so you could say this equals this, this equals this. You can actually get 3 equations, right? But you only really need 2. When you have 2 unknowns, you need 2 bits of information. When you have 3 unknowns, you need 3 bits of information, etc., etc. All right, so how do we go with 6? I think I've seen a few people, and that's okay. Is Andre and Michelle irritating us? Okay, let's put Andre and Michelle, tell them off a little bit. So Andre and Michelle have 65.25 between them. Andre's money is 2/3 of Michelle's amount. How much money does each have? So we can say A is the amount that Andre has, and M is the amount that Michelle has. Right, so they have 65.25 between them. So what would that statement then be? Yep, so A plus M, by the way, my initials. Andre's money is 2/3 the amount of Michelle's money. Andre's is 2/3 of Michelle. So imagine if Michelle had $30, right? Andre's is 2/3 of that. $20, that's right, because 2/3 times 30, oh, there's our fraction work again, gives me the $20. So we're going to say that Andre will be 2/3 the amount of Michelle. Can we handle that? Okay, and again, because I've seen A equals sub. I'm going to go the sub, right? Sub, in place of A, I'm going to say that is 2/3 M plus M equals 65.25. My year 11s at the moment, we're doing this thing called the unit circle, and they have to work with fractions. And it's doing the heads in. So we're going back to old school, and we're going, if I have a whole pizza, right, the pizzas are cut into thirds. So I've got a whole pizza. So how many slices if we're cutting into 3 in a whole pizza? 3 plus another 2 slices. How many have we got? 5. So 2/3 plus a whole is 5/3 equals 65.25. Now, how do I get rid of a times? 5/3. Divide 5/3, or times by 3, divide by 5. It's up to you. Yeah? So we should be able to get what Michelle has. Is that what was bothering us? I'll write that down just in case. So, therefore, M equals the amount that Michelle has is $6.25, right? You can either divide by 5/3, or you can say that 65.25 times 3, divide by 5, and you go, oh yeah, that's the whole fraction stuff that we did. When you're dividing by a fraction, you flip the divide to a times, and then you flip this, and you go, oh yeah, that's because we were timesing by the divide by 3, getting rid of the times 5, divide by 5. My God, makes sense. Who would have thunk it? Not us. Milk is sold in either 600 mils or 1 litre cartons. A supermarket manager ordered 79.8 litres of milk and received 93 cartons. So here we go, because we've got lots of information, lots of numbers everywhere. So what are we meant to let X and Y be? It's in the last line. How many of each size carton does the manager receive? So we're going to say let X equal how many size of each carton? So the number of, what do you want X to be? The number of 600 mils. And Y is the number of 1 litre. So how many cartons has he got altogether? 93. So is everyone happy that it's X plus Y equals 93? Yes? And then he's got the number of, we'll go colour coding here, he's got the number of litres. So if X is the number of 600 mils, how many mils is in a litre? Mils in a litre, that's right. So 600 mils is 0.6. Yep, 1,000 mils in it. So are we happy that the next line, who wants to have a go at what the next statement would be? 0.6 times the number of those cartons plus 1 Y, and that's where sometimes that's hardest for us. Like if it was 2 litres, it would make sense to us, but it's 1 times Y, so we just write Y equals 79.8. Okay? Now, again, I'm saying for some of these worded questions, you could just go to technology, but for this one, I'd be so tempted not to go to technology. Why? There's your clue, by the way. Why? The Y's have the same coefficient. So couldn't I eliminate those just by simply subtracting? What's a whole X? Take 0.6 of an X. 0.4 of an X. 1 take 1 is nothing. 93 take, well, you can do that, and away we go. So